Hello guys, in this lesson we are going to see about 7 naming reactions that is given under the chapter hydroxy compounds and ethers in your plus 2 book, second volume. Alright, the first reaction, that is Dow's process. It's a process by which phenol is synthesized. Okay, and all other reactions, Scott and Bowman, Williams and ether, Kolb-Schmidt, Riemer-Tiemann reaction, Thallian reaction, coupling reactions or reactions of phenol. சரியா 7 நேமிங் ரியாக்ஷன்ஸில் வந்து ஃபஸ்ட்டு கொடுத்துருக்கு இல்லையா டவுஸ் ப்ராசஸ். இது பார்த்திங்கன்னா இது ஃபீனாலை சிந்தசைஸ் பண்ணக்கூடிய ஒரு ரியாக்ஷன். மற்ற எல்லா ரியாக்ஷன்ஸும் பார்த்திங்கன்னா அது ஃபீனாலுடைய ரியாக்ஷன்ஸ். ஃபீனாலிருந்து நம்ம என்னென்ன சிந்தசைஸ் பண்ணலாம் அப்படிங்கிறத நம்ம வந்து மற்ற ரியாக்ஷன்ஸில் தெரிஞ்சுக்கலாம். ஆல்ரைட், ஸோ ஃபஸ்ட்டு phenol. So before we go in detail about all these reactions, first let us know what are the products we are going to get from these reactions. சரியா, ஃபஸ்ட்டு டவுஸ் ப்ராசஸ் மூலமாக நம்ம என்ன சிந்தசைஸ் பண்ண போகிறோம் அப்படின்னு நம்ம தெரிஞ்சுக்கணும். ஓகே, ஸோ இந்த மாதிரி தெரிஞ்சுக்கிறதுனால நம்ம வந்து எக்ஸாமில் கன்ஃபியூஸ் ஆக மாட்டோம். டவுஸ் ப்ராசஸ் we are going to get only phenol. Phenol தான் வரப்போகுது. டவுஸ் ப்ராசஸ், இட்ஸ் a process by which phenol is synthesized. நெக்ஸ்ட்டு ஸ்காட் அண்ட் பவுமன் ரியாக்ஷன் வந்து இட்ஸ் ரியாக்ஷன் ஆஃப் ஃபினால், ஃபினாலுடைய ரியாக்ஷன். ஸோ ஸ்காட் அண்ட் பவுமன்லேருந்து என்ன வரப்போகுது அப்படின்னாக்கா we are going to synthesize ester. Okay, so what is the functional group for ester? COO will be the functional group for ester. Phenolku OH will be the functional group. Okay, next Williamson ether. So from the name itself ether is given. Okay, so that means you are going to synthesize ether from this reaction. From phenol, ether will be synthesized by Williamson ether synthesis method. Okay, so what is the functional group for ether? O will be the functional group for ether. Next, Kolb-Schmidt reaction. Okay, so this is a reaction by which we are going to synthesize salicylic acid. Salicylic acid from phenol. Okay, salicylic acid nothing but benzene ring, OH and then COOH. So this is the formula for salicylic acid. Alright, and Riemer-Tiemann reaction from phenol. Through this reaction we are going to synthesize salicyl aldehyde. Salicyl aldehyde. Okay, from phenol. Okay, it's nothing but just put a benzene ring, OH and then aldehyde group here. So this is what we are going to synthesize. And then Thallian reaction is a reaction by which we will be synthesizing phenolphthalein. Phenolphthalein. Okay, which is used as an indicator in the acid-base reaction. Phenolphthalein will be synthesized from the phenol through this reaction Thallian. Yeah. Next, coupling reaction. So coupling reaction on the from phenol you will be preparing a dye. Okay, that is para hydroxy azobenzene. Okay, we will see all these in detail now. First you should know what's going to be the product. Okay, through these reactions. So Dow's process, from Dow's process we will synthesize phenol. Okay, Scott and Bowman we will synthesize ester from phenol. Williamson ether we will synthesize ether from phenol. Kolb-Schmidt we will synthesize salicylic acid, and Riemer-Tiemann we will synthesize salicyl aldehyde from phenol, and Thallian we will synthesize phenolphthalein from phenol. Coupling we will synthesize a dye para hydroxy azobenzene from phenol. Okay, so let's see in detail about all these reactions now. First, Dow's process. Let's see about this. It's a process by which phenol is synthesized, right? Phenol is synthesized from chlorobenzene. Chlorobenzene and the phenol varudhu. சரியா, ஒரு benzene ring போட்டு chlorine போட்டிங்கன்னா it's a chlorobenzene. Chlorobenzene hydrolyzed. Sodium hydroxide ஓட போட்டிங்கன்னா அது hydrolyzed ன்னு சொல்லணும். Hydrolyzed with sodium hydroxide at 633 Kelvin, 300 bar pressure. சரியா, first you get an sodium phenoxide. You get an intermediate product, that is sodium phenoxide. Sodium phenoxide எப்படி போடுறது, benzene ring போட்டு ONA. இப்போ என்ன ஆகுதுன்னா, so what is happening means NaO substitutes here. Okay, and Cl and H goes as a byproduct. So yeah, ON inge substitute agum. This is sodium phenoxide. It's an intermediate product. It is formed before the formation of phenol. Then after that, this is treated with the dilute hydrochloric acid to form phenol. So yeah, benzene ring put OH putting a phenol. So what happens here? Na and the Cl from HCl is removed as NaCl. Then H substitute in the place of Na to get phenol. Okay. So Dow's process, a process by which phenol is prepared from chlorobenzene. Chlorobenzene treated with the sodium hydroxide or hydrolyzed with the sodium hydroxide. First sodium phenoxide is formed and then phenol is formed on treatment of this sodium phenoxide with the dilute hydrochloric acid. Okay. So this is about the Dow's process. It's a process of synthesizing phenol from chlorobenzene. The rest of the reactions are reactions of phenol. From phenol, we are going to synthesize ester. Okay, by the reaction Scott-Bowman, that we will see now. So Scott-Bowman reaction. It's a reaction of phenol. So I am writing phenol. Okay, so what will be synthesized? Ester will be synthesized. What's a functional group for ester? COO is a functional group. Okay. Acid chlorides. Phenol is treated with acid chlorides. Okay. Some examples of acid chlorides: acetyl chloride, benzoyl chloride. So these are the acid chlorides. So in this reaction, phenol is treated with the acid chlorides such as acetyl chloride or benzoyl chloride to form ester. Okay. So first let me write acetyl chloride. How will you write that? CH3COCl is the acetyl chloride. So yeah. So this is phenol. This is acetyl chloride. So what happens is Cl and H removed as HCl. So remaining portion we have to combine. So in your book this phenol is written in the formula form. So that is C6H5OH. So like this also we can write. H and Cl will be removed and remaining portion has to be combined. So first let me write this CH3CO and then O and then C6H5. So look at here. So COO is the functional group. Okay, for the ester. Now let's name this. So this is named as phenyl. Two carbons are there. Ethanoate. OATE refers ester. Ethanoate. Now we will also try with benzoyl chloride. Phenol benzoyl chloride is C6H5COCl is benzoyl chloride. Okay. So likewise Cl and H removed as HCl. So remaining C6H5COO is a functional group, right? Then C6H5. This remaining portion we have to combine. Okay. This is named as phenyl benzoate. Benzoate. O8 refers to ester. So we have completed now Scott-Bowman reaction. It's a reaction of phenol. From phenol, esters are synthesized. Esters like phenyl ethanoate and phenyl benzoate by treating it with the acetyl chloride and benzoyl chloride. So this reaction occurs in the presence of base sodium hydroxide and then pyridine. We can just simply write Py. Okay, in the presence of sodium hydroxide and pyridine, just write Py. We can also say like acetylation of phenol, benzoylation of phenol. is the Schotten-Baumann reaction. Acetylation, okay, or benzoylation of phenol is the Schotten-Baumann reaction. So next we will see Williamson ether synthesis. Williamson ether synthesis, phenol. Okay, so I have written phenol here. You can also write it as C6H5OH also. It is given like this in your book. So I have written like this, right? Phenol with the sodium hydroxide. First give sodium phenoxide, ONA. Alright, the byproduct will be water only. So in the place of H, Na substitute. So this is sodium phenoxide. Sodium phenoxide then treated with the alkyl halide such as methyl iodide. Okay, alkyl halide, it is methyl iodide actually. Alright, so what will happen? NaI get removed. Okay, NaI will be removed as a byproduct. Then you have to substitute CH3 in the place of Na. OCH3. So it's a kind of, O is a functional group, right? It's a kind of ether. Phenol reacts with sodium hydroxide to form sodium phenoxide. Then it is treated with the alkyl halide such as methyl iodide to form methyl phenyl oxide or methoxybenzene. Methoxybenzene. And there is a common name for this, anisole. Benzene ring OCH3 is anisole. Okay. So in the exam, if they ask you prepare anisole from phenol, then anisole is a kind of ether. You should know that. And ether can be synthesized from phenol by Williamson ether method. Okay. So next method is Kolb's and Rimmer-Tiemann, we will see now. Kolb reaction or Kolb-Schmitt reaction, both are same. Okay, so first you should have in mind that we are going to prepare salicylic acid from phenol by this reaction from phenol, right? So I am writing phenol here, phenol. Here also sodium phenoxide is formed as an intermediate. Phenol is first reacted with the sodium hydroxide to form sodium phenoxide. Then sodium salicylate is formed by reacting this sodium phenoxide with the carbon dioxide. Okay, at a temperature of 400 Kelvin and 4 to 7 bar pressure. So what is formed? Sodium salicylate. How will you write sodium salicylate? OH COONA. The carbon dioxide gets attached here to the ortho position. Okay, and the Na shifts over there to the COO group. So this is the structure for sodium salicylate. Okay, then this is now hydrolyzed in the presence of H plus acid, hydrolyzed in the presence of acid. So we should write like this to get what? Salicylic acid. So in the place of Na you should just put H, so that is salicylic acid. OH, don't forget to put ring here. Okay, COOH. So this is the structure for salicylic acid. Preparation of salicylic acid from phenol is the cold reaction or cold Schmidt reaction. First, phenol treated with NaOH to form sodium phenoxide. Then that is treated with the CO2, carbon dioxide, at 400 Kelvin, 4 to 7 bar pressure to form sodium salicylate first. Okay. So you should put H here and then here COONA, that is sodium salicylate. This on hydrolysis in the presence of acid gives salicylic acid. So next is the Reamer-Tiemann reaction. So it's a synthesis of salicylic aldehyde. So in the presence of acid group, there will be CHO, aldehyde group. So phenol to salicylic aldehyde is the Reamer-Tiemann reaction. So that we will see now. Reamer-Tiemann reaction, what is that? Synthesis of salicylic aldehyde from phenol. If there is an aldehyde group CHO here, then it is salicylic aldehyde. Okay. So first it is treated with sodium hydroxide and chloroform, CHCl3. Okay. So this is chloroform in the presence of sodium hydroxide. An intermediate is formed here. So that is, so since NaOH is there, sodium phenoxide, and as a substituent from this chloroform CHCl2. Okay, so one Cl and H goes as HCl. So this is an intermediate formed. So byproduct is HCl. Okay, now this is then treated with the again NaOH. So first both NaOH and chloroform we have to write. Okay, this is treated with now NaOH alone. So what happens is CHCl2 gets converted to CHO. It means only O is substituted here. 2 Cl is there, right? So one NaCl and HCl will be removed as byproduct. But don't concentrate more on the byproduct. The main product formed as ONA. Okay, so this group is converted to aldehyde group CHO on treatment with the sodium hydroxide. Now ONA has to be converted into OH, right? So treated with the acid H plus ion to get salicylic aldehyde OH CHO. That's it. Okay. So Reamer-Tiemann reaction, put phenol, chloroform and NaOH. You should, this is very important. Okay. Chloroform and NaOH has to be treated so that this get converted to ONA, and CHCl2 is substituted here, attached here to the ortho position. So that's an intermediate. It's an unstable one. This is again treated with NaOH. So that CHCl2 is converted to CHO. Then ONA is converted to OH by treating it with the acid. That's it. So Reamer-Tiemann reaction. So next we will see remaining reaction, Thallium and coupling. Thallium is a reaction by which phenolphthalein is prepared from phenol. Okay, 2 phenol reacts with 1 phthalic anhydride. How will you write phthalic anhydride? Just put benzene ring. Okay, C double bond O, C double bond O, O. So this is phthalic anhydride. From this phenolphthalein is prepared. So how to write this phenolphthalein? So just put a benzene ring, write all these except this. Here only the reaction is going to happen. C double bond O, okay, to this carbon. So everything is, we have to write everything except the double bond O here. To this carbon, okay, the oxygen is actually removed. just put two bonds and then two phenols here. These two phenols should be there. Okay, so this will be the structure for phenolphthalein. This reaction occurs in acid medium, so you just write sulfuric acid here, H2SO4. So this is phenolphthalein, which is used as an indicator in the titration, acid-base titration. So the last reaction that we are going to see is coupling. Coupling reaction. It's a reaction by which dye is prepared. Para-hydroxyazobenzene is prepared from phenol. First, let me write benzene diazonium chloride. This is benzene diazonium chloride. In your book, it is given in this form. Benzene, it's in the ring form. So I am writing like this. Benzene diazonium chloride react with the phenol. So phenol, here we are writing in this way. What happens? There will be hydrogen here. That hydrogen and this Cl is removed. Actually, there is a double bond between the nitrogen. So benzene ring, N, double bond N, Cl is removed. Then again this benzene ring, OH. This group is azo. Okay, para-hydroxyazobenzene. OH is in the para position. Para-hydroxyazobenzene. It's a kind of dye. This reaction occurs in base medium, NaOH, at 273 Kelvin temperature. Okay guys, so in this class we have seen 7 important naming reactions from the chapter hydroxy compounds and ethers. Meet you all in next class. Thank you.